I'm now going to demonstrate how we can use an Excel spreadsheet to reproduce the calculations of mean and standard deviation of patient height, which we've just done manually. Here's the finished result, a spreadsheet which shows the height of each individual patient and from which we've calculated the mean and the standard deviation in a couple of different ways. And we've also binned the data into Histogram and displayed that graphically. So let's just close that and I'll show you how to reproduce it from scratch. The details of the way you do this will vary from one system to another. Here I'm using Windows XP and Excel version 2003. The details on your system may be different. First, I want to start the Excel spreadsheet. There are several ways of doing that. I'm going to do it by clicking on the Start button and then selecting All Programs, and then from the available programs we have Microsoft Office and Microsoft Office Excel 2003. Now Excel has opened with an empty workbook. Let's start by typing a heading in this first cell for patient. So we type the word patient in the first cell and then complete it by pressing return. So I enter 1 and return in the first cell. That automatically enters it and moves the cursor onto the next cell. So I can put 2, 3, 4, 5, 6, 7, 8, 9, 10, pressing return after each one completes that cell and moves down to the next cell. Now if I click on cell B1 here and type in height, press return, I can enter the height of each patient. The first patient has a height of 180 centimeters. I press return to enter that and it moves on to the next cell, and the next height is 154, return, 155, 158, 169, 177, 165, 182, 192 and 168. Now if you remember, to calculate the mean we need to add those all up. So let me enter total in this cell A12, and then I'm going to create the total in cell B12. There are several ways of doing that. The easiest is to put the cursor over cell B2, the first height, click the left mouse button, hold that down and drag down over the cells and the next empty cell at the end where the total is going to go. When I release that, I can now click on the little icon here which is automatic sum. When I click that, Excel is clever enough to realize that I want to add up all those numbers and put the total 1700 in the empty cell underneath. In fact, if we click on that cell, you can see that it's automatically entered the formula equals sum of B2 to B11, the sum of those 10 cells above it. We also need to know the number of patients. In this case it's easy, we know it's 10, but let's just show how Excel can work that out for us. If I put number in this cell here, then we can enter a formula in cell B13. I click on that cell and start typing equals, which tells Excel I want to enter a function or a formula, and the formula I want is count, C-O-U-N-T, then open brackets, and then the range of cells I want to count. I do that by putting the cursor over the first cell and then dragging down over all the cells I want to count. Just those 10 cells, and it's entered B2 to B11 automatically for me, and I put a close brackets to close that formula and then return, and it's added up a count of 10 cells, which we know is correct. Having calculated the total and the number, we can now calculate the mean, and if I type mean into this cell here and press return, we know the formula for mean is the total divided by the number. So if I put equals to say I wish to enter a formula, I can then point at the cell containing the total, cell B12, and then I want to divide that, so I put a slash meaning a divide, and then I point to the cell here containing the count, B13, and then press return, and that completes that calculation. The mean is 1700 divided by 10, which is 170. Actually, of course, there's an easier way to calculate the mean. We can type in this cell below a formula. I put equals average, which is the function that calculates the mean or the average, an open bracket, and then I point at the range of cells I want to average, all of those down there, dragging over that B2 to B11, and a closed bracket to complete the formula, and press return. I get exactly the same answer of 170. The standard deviation can be calculated in the same way. So if I enter SD as a heading in that cell, and then point here in cell B16 where I want to put the formula. The formula is equal to, say I'm entering a formula, STDEVP, standard deviation, open brackets, and once again point at the range of cells, drag down with the left mouse button over those 10 cells, and a closed bracket to end the formula and return, and 11.966. That's probably a bit more precise than we really need. We don't need all those decimal places. So if I click on that cell and select Format from the menu at the top, Format Cells, and select Number from the Cells menu, and that gives me by default 2 decimal places. 1 will be quite enough for this, so if I reduce that to 1 and say OK, that changes the format there to 1 decimal place, which is rounded to 12.0. So that's how we've calculated the mean, 170, and the standard deviation, 12.0. Of course, Excel has lots of ways of doing things, and there's an even easier way. If we click on Tools, we'll see we're looking for a data analysis tool. If it doesn't appear on the menu there, click on this down arrow, and that gives you some more options there. You see, data analysis isn't available. Don't worry, because if it doesn't appear, it's just an add-in that we can add. So go down to add-ins, and then you'll see a list of available add-ins. Put a tick against the analysis tool pack and say OK. And now when we go back to the tools menu, we'll see data analysis does appear. Select data analysis, and there are a range of data analysis tools available. The one we want here is descriptive statistics. Select descriptive statistics and say OK. And we get a menu to fill in. Input range is the data that we're going to analyze. Click on that cell for the input range, and then go and highlight the input range here, starting with the cell called height and down to the last number. Because the first cell here contains the label height, I click on labels in first row to indicate that that first cell doesn't contain data, it contains a label. Then we have to say where we want the output to go. So click on output range, click in the cell here where you want the output range to go, and let's point to somewhere like E1, a suitable place to put the output. And then we have to say what output we want. Let's just have summary statistics, and then click OK, and lo and behold, Excel calculates everything for us. It's a bit squashed here, but if we widen column E by clicking between E and F and dragging across with the left mouse button, we can now make that readable. And we see we have a mean height of 170, which we've already calculated. Don't worry about the standard error, we'll come back to that later. The median value, remember, is the value where half of the measurements are above and half of below, is 168.5. The mode doesn't exist in this data. The mode is the most frequently occurring, and nothing occurs more than once, so there is no mode. Now, standard deviation is calculated at 12.6, whereas we had 12.0. Don't worry about the difference there. We'll refer to that in a later lecture when we talk about sampling. The variance and the kurtosis and the skewness are other measures that it also gives. It gives the range from the minimum of 154, the smallest value, to a maximum of 192, and a sum of 1700 and a count of 10. So you see that analysis tool has quickly given you all of those numbers. You didn't even need to do the calculation in the first few cells which I've just done. But what if we want to bin the data into a frequency histogram? To do that, we need to define the edges of our bins, and so I'm going to type in a few cells here. What we do is put in the upper limit of each bin. So I'll put in a cell with 154 centimeters as being the top of one bin. The next cell down I'll put 164, and then 174, 184 and 194 for the tops of our bins. Now there's a tool that I can use, again under Tools, Data Analysis, called Histogram. When I select that tool and say OK, the input range is going to be the 10 heights that I want to put into a histogram. This time I didn't select height, the cell containing the word height, as a label, so I don't check this cell saying label. The bin range, I click on the cell for bin range and then point to where the bin range is, and those are these numbers that I've just entered here for the upper limits of the bins. The output range, I'm going to put click the output range and then click in this cell to say that I'm going to type in the point to the output range, and I'll point to this cell just here, cell C20, just above where my bins are. And that should be sufficient to create the histogram. When I click OK, Excel creates this these numbers showing that the first bin has a frequency of 1, the next bin a frequency of 2, and then 3 and 3 and 1, as we've found before. If we want to produce a histogram of the data as a nice chart, then we select the numbers we want to use, 1, 2, 3, 3, 1, and select the chart wizard here. The chart wizard gives us a choice of different types. We're going to use this column type, which gives us the right sort of display, and then select next. And if we go to the series tab here, we can define the Y values already been defined as the cells we've selected, but the X values, if I click in there, are going to be these bin names there. And then if we come to next, we get the option to put in the category, a label for the X-axis, which is going to be height, and for the Y-axis, which is going to be frequency. And then we want the chart to be in this sheet, so we leave that selected and click Finish, and we get a graph produced in this sheet, which we can drag to somewhere suitable just by clicking the mouse over it and dragging. Oops. So you see there we have recreated the whole calculation and the display in Excel, which is much easier than having to do it all by hand or even with a calculator. So you never really need to have to do the manual calculation at all unless you want to. Just to save our results, we'll do File, Save As, and give it a name to save the spreadsheet for future use. Let's call it Heights.